All right, so I'm going to talk about Reason. How we go about this is I will tell you about the benefits, explain you a little bit about the language, and then go into ReasonReact. So the first thing to know, when I tell you I'm going to teach you a language in one talk, don't panic, because Reason is actually built to be a friendly syntax for JavaScript developers. Let's look at it. Here we have basically declaring a variable. In Reason, we call it binding a variable to a name. But it's pretty straightforward. We create the meaning of life. We have functions. There's no function keyword. We just do arrow functions. Simple as that. We can create lists of strings. No magic, that's an if condition. The only thing that I should mention here that's definitely different is the last statement in every scope, local scope, in this case the curly braces, is always returned. So there's no return keyword. That's the first thing. So we already heard from Ken Wheeler. By the way, give him a shout out for having so much love to Reason and for just being Ken Wheeler. This thing is based on OCaml. And what this means is there's OCaml, which is this 25-year-old, maybe even older language, functional programming language, which allows you to do mostly functional programming, but in almost all the cases you can bail out and do imperative stuff. You can do mutable stuff. By default, it's immutable. But it got this funky ML syntax, and you need to get used to it. But what the Reason team did is they just put a JavaScript-like syntax on top of it because they want to make it friendly to JavaScript developers. In the end, both compile down or like they transform to an OCaml AST, and that means like from there on we can use all the ecosystem, all the leverage, everything that has been built for the last 25 years for OCaml, and that's pretty cool. Let's skip the fuss. Let's go right into, we want to create something like an object or map. Let me tell you, this doesn't work. There will be a compiler warning, because in Reason, same as, it's not like JavaScript, where you simply can create an object. I mean, we have objects. I told you we can always bail out, where we can create completely dynamic fields. The record, the standard type of defining like such a data structure, we have names or keys and values, is you have to actually declare the type beforehand. And then suddenly the type, the compiler error will go away. And you can define chain. And then again, looks like JavaScript because you can create team and you use the same age because you spread out chain and you just overwrite the name, and that's pretty cool. Obviously, it compiles to JavaScript, Reason as well as OCaml, because of a tool called BuckleScript. That's a compiler that was created by an engineer at Bloomberg. Now he's freelance, working from China, and he's like full-time working on this. And this is the cool thing about BuckleScript. Like, this is freaking fast, like faster than usually everything you've seen before. Like a couple of milliseconds, usually like 3, 4, 5, and you're done. It compiled everything. It compiles. It does exactly matches like one Reason file to one JavaScript file, but it's freaking fast. And that makes it a blaze to work with. All right, and as we already heard before, like it not only can compile to JavaScript because all this OCaml toolchain, we have bytecode, but for me especially interestingly, we have native code, so we can compile down to the platform directly. Maybe Linux, Darwin, like OS X, or Windows, and there's even people working on ARM. And for me, like, especially like for the last 2 years, I was working on and off on the CLI tool, the serverless CLI. And you need to constantly, when you use this tool, you constantly invoke it. But this thing got really big, and in the end, we were loading so many modules that just the boot up time became 400 milliseconds. And like the experience, to me, it was horrible. There's ways to get around it, but you're just working around it. And in the end, you never get as fast as native code. And I really like the fact that this ecosystem, or these languages, you can compile them to both. Obviously, there's hurdles, but we're going to get over them. the next big thing, what I'm really excited about, is that Reason comes with formatter, reformat out of the box. So no discussion about like, should this be in the next line or this line? Do we have a space there or not? What it does is it takes your code, it actually transforms it to an AST, and then it prints it out until based on a rule set. And matter of fact, Prettier was inspired by that idea. So James Long, who initially built Prettier and still working on it, like he used reformat and he really liked it, and that gave the idea to work on Prettier. And yeah. And the best thing about this doesn't have options, so no discussion about semicolon or not. Simply Reason has semicolons and that's it. All right. The one big thing is it's a statically typed language. So what? Give me a break. Yet another statically typed language. Why the hell? Let me tell you one thing. We can do better. That's what I believe, and that's why I think people like Yuri and Ken and so on, they're excited about this because they already got the glimpse of it by trying it out. And I think if in 20, 30 years, if you think back, like what we do right now, it will look more like this. Like we do monkey coding. We are like using primitive tools to build cool stuff and are really excited about it. But in 20, 30 years, this will be like, wait, man, this was really tough. Things should be way easier. And let me give you an example. Fairly simple one. Here we have a JavaScript array just showing like saving some pieces, chess pieces. They have a kind, they have a color, they have a position. We can use TypeScript to enhance this. And I mean, I'm totally supporting what Yuri yesterday said. Like, if you have the choice between typing and not typing at all, go for typing. If it's TypeScript, like, let's do it. If you can't use Reason or whatever, typing is always more helpful, and then not going at all for it. But there's one thing that trips me up in TypeScript all the time. Is this piece here. Like, I mean, it's pretty obvious that in this scope, in this file, like what I'm mapping over here is the pieces. So the compiler should be possible, like should be able to infer like that I'm actually using the pieces here. But the problem is semantics, because how semantics, like TypeScript is a superset of JavaScript and so on, and you have this dynamically created objects. And then you need to basically put a layer on top of it to actually make it work. And you write a ton of type definitions, and then you get into these arguments. Well, TypeScript makes me slow, and the other people are like, I would just want to prototype fast, and it's like really annoying. But if you use Reason, I mean, it looks a bit different, the last line, because it's a different standard library, and in the end, it's a different language that just looks like JavaScript at this point. But the benefit here is like, I'm just defining the type on the top, and the rest, like the compiler does everything for me. It basically understands like, hey, this is, you're working on pieces here right now. You're mapping over these pieces. But, and in fact, like if you want to bail out, and if you really want to get kinds of projects in another module or so, you can explicitly still override it and declare it and say like, hey, this is not, you're not meant to use the pieces of this file. You can use the projects, which also have a kind of another file. But this is what is called type inference. And this is like the one big thing for me about Reason, while I enjoy working with it, because you get a statically typed system, but on the other hand, like most of the stuff is completely inferred, and you write very little types. And this is a place, because you still have this like full type safety, but on the other hand, you can write really fast code and prototype and be efficient. All right, is this all? No, definitely not. Next data structure, variance. This is something you probably have not seen as like if you only use JavaScript, you're probably not familiar with this. The closest thing you might have heard of is enums. So let's say we have a type direction, and this can be then of basically describing a data structure, which can be either like this or that or that or that or that, and you can do as little as many options as you want. And here it's like up, down, left, right. And then you can simply assign one of these values or bind it to a name, in this case move, like move left. It's different though compared to enums, and that's why it's called, like in computer science, it's called tagged unions, because compared to enums, we can actually attach data to it. So we could say the direction should not be only just like one of these values, but it can contain stuff, in this case an integer. And here we can basically describe, like in a game it would be like move left twice. Of course, you don't, like the data doesn't need to be the same all the time. When we, for example, define a request which has loading, error, and success, like the data inside error, which could be an error code, is completely different than you have in a success state. And this is really important because then you can get into like, it makes certain cases, like certain bugs impossible. Because you like, if you're in a success state, then you have the data, but not the other way around. And I don't want to go too much into it because like a lot of what Patrick is talking about in next talk is like exactly around this thing, like making unrepresentable states completely impossible in your code. So people cannot even mess up. There's one more thing though, let's get back to our chess example, is to give a sneak peek. If I have the color, like before it was a string in JavaScript and TypeScript. I mean, with TypeScript, I'm not too familiar with it. I think you can do enums as well now, not sure. But you basically, like, so if this works with TypeScript, then use this pattern as well. Like, you can limit the developers that are using your code, this piece of code, to either have black or white, and basically make sure that the compiler always wants them. If they make a chess and use color yellow, like the compiler will warn you, hey, this is not legal what you're doing here. And same as with the kind, and especially for like. Fun fact: we did this workshop 2 days ago, and people were. We told them like, yeah, do the chess kinds, all the pieces, and completely different names because most of us were non-native English speakers. So for the knight, a lot of people used the string horse, or for the bishop runner. And if you do that with a string, like you mess up and you don't even notice. But if you use a variance, such a enum-like structure, the compiler will warn you if you use the wrong thing because the horse simply doesn't exist here, or the runner. All right, next cool feature, pattern matching. So pattern matching, similar to JavaScript, you basically have a switch statement. Well, it's actually not a statement, but I'm gonna get into that. And you have the value, and then you can match to, on the left side you have the pattern, and then on the right side, you get the case that you actually want to transform it to whatever you want to do in the scope block. Example would be, you can pattern match a number. So if you have a lamp UI display text, like the data is coming in as an integer, you have 0, you want to show off. If it's 1 on, in every other case, this underscore has a special meaning in this case. It's basically like match all other cases, always show off. So it doesn't break, that we basically cover all the cases. But as I mentioned, it's not a statement, it's actually an expression. So whatever happens here, I told you, like, every time when you, like, I mean, this looks a bit like a function. So basically off is returned, and then you can assign it to, or bind it to this display text. And that's really cool because what happens here is that, that a lot of your logic, like if-else conditionals, and then you have like lets and the override of all of that, you just write into this switch pattern matching expression and you assign it directly. Let's look at a bit more complex example of pattern matching, because you can With variance, it's especially interesting. So here we have the request variant again. And what you can do is, here we can not only match on it, but we can also get out the data of it. So here in the arrow, we can get the code and actually show it and return it in there. In a success state, we can get the data and we can do stuff with the data. So we can, while pattern matching on the same time, so we match on the success state, we can also at the same time extract data out of it. But it's not only extraction, you can also match directly on stuff. So we could say, if you have loading, that's pretty cool, do stuff with loading. If you have specifically this arrow, with the error code 401, like I want to do something else than with error code, you could extract the code and do the if-else, basically do an if-else or another switch statement in there. But if you do it like this, and you can even do it nested, yeah, you can do like as many deep nests pattern match as you want. The good part is a lot of like the conditional logic that you have with if, else, switch, or whatever. It boils down mostly to one switch statement where you do a little bit of fancy pattern matching, and it reduces the code to be very simple and fine. Cool. That was pattern matching. Next feature. Actually, for this one, I wanna like go a little bit around the story. Who of you knows this decent gentleman? Raise your hand. All right, 2 people. Okay. So actually, let me find the name. So this is whoa, where are you? Okay. Oh, well, before I tell you more about it, like. This guy, he received the Turing Award. He teaches at Oxford, computer science, obviously. And he invented a quicksort algorithm, like long before most of us were born. And he invented CSP, like for concurrent process communication, like really, really crazy fancy stuff. And his name is Sir Charles Anthony Richard Hoare. Very decent gentleman. Did a lot of cool stuff for us in computer science. We rely on a lot of his work. But 2009, he actually like did a talk at QConf in London, and he said, "I call it my $1 billion mistake." And now I'm gonna read the full statement, the paragraph, so we don't mess up anything. I call it my $1 billion mistake. It was the invention of the null reference in 1965. At that time, I was designing the first comprehensive type system for references, yada, 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 object-oriented languages. My goal was to ensure that all use of reference should be absolutely safe. Okay, that's cool. We like that. We like type safety. With checking performed automatically by the compiler. Cool. But I couldn't resist the temptation to put in the null reference. That was his fault. Simply because it was easy to implement. Come on. This has led to innumerous errors, vulnerabilities, and system crashes, which have probably cost $1 billion of pain and damage in the last 40 years. Yes, man. I suffer. At university, I suffered from this one. Java, null pointer exception. And when writing JavaScript in my day-to-day, I still suffer from this one. Thank you, Tony. So let's take away there's 2 lessons to take away from this. Like, really, don't implement anything just because it's easy. This is really important. And the second one, null is really bad. So how can we let Tony sleep again? Because he probably has nightmares from null. Let's just use reason or OCaml, because null doesn't exist there. Woo! Well, you might think, okay, that's cool, but what if I have a contact list and I have friends in there and there's an email and there's a phone number, and from some of them I have an email, some of them I have the phone number. You need some kind of like way to declare like this exists or this doesn't exist. And what we have in Reason and OCaml out of the box is the option type. And this is like the preferred way to deal with this case. You can basically implement it yourself, but this is how you should go about it. Basically it means like it's a type where that can be either none, and that's a variant. Something that's what I mean. You can implement this by yourself. Like it's just a simple variant data structure that we just learned like 5 minutes ago, or it can be some with anything in there. And then what you can do is you can pattern match on it. And the best part about it is like if you want to prototype fast and you don't care at this point about like the none case, it's completely fine. Just leave it out. The compiler will give you a warning and say like, hey, man, just you screwed up here. You left out none, but it's okay. I let you go on. You can prototype your code, but obviously you can even check it in. But like at best case, like if I would review your code and this would throw out this warning, I would tell you like if this has to go to production, make sure you cover the none case as well. All right. And I told you we build up for ReasonReact. So one last thing before we actually get into ReasonReact, functions. We have seen this before. Add functions, pretty straightforward. Nothing to add there. There's one thing though about there's a couple more things that you can do fancy things in Reason with functions. But one thing that we really need for ReasonReact is so-called label parameters. And that means like here I have I'm basically declaring a function with two label parameters, first name, last name, and then I concatenate it to get the full name. The cool thing is, if you have labeled parameters, you can also use the labeled parameters, then like use their labeled arguments, and you can flip them around no matter what. And that's exactly how kind of like prop types behave, because instead of passing an object, we have a native feature in this language for this kind of behavior. Like, as long as you name it, you're good. Just you can flip it around, doesn't matter, and you can provide it. And that's where ReasonReact comes in. Woo! Let's start simple. Stateless component, we just render hello. It starts out with, it's a bit different because like in React itself, you can either have this function or you can have a class component. Here, what you do is you create a module with a make function. That's the way it is. That's the way how they basically created the React bindings. By the way, like ReasonReact is not a re-implementation of React. It just uses React. It binds to React, and it does a couple of things. It changes a couple of things to make it more appealing to Reason and use the features of the language. And in the end, like you have the first file, which is the greeting RE file, and then you have this make the function. We spread out the stateless component. We override the render, and we just do ReasonReact string. That's one thing that is kind of annoying, but that's what you need to fulfill the type system, because when inside render, like when you render like H1 is JSX, so we have JSX in ReasonReact, and it compiles to react.createElement, but you need to do the same thing with the string because to fulfill the type system. Okay, let's look into parameters. I told you about labeled arguments, so what we have now is, instead of getting props, we actually can get each argument by itself, each parameter by itself. And yeah, and so we can simply get the name and enhance our greeting to accept one more parameter, one more argument, Helsinki. Cool. How about state in ReasonReact? I will show you a quick application. That is like, it's a counter. You can add one, you can add two at a time, and you can reset the whole thing. Nothing fancy. So let's create this component that actually can do this stuff, this application. Well, we define a state because we want to be type safe. It's a count, it's an integer, pretty straightforward. But there's no such thing as like set state in ReasonReact because they found like it's not really functional and we can do better. We have variance at our disposal, so why not build kind of a mini Redux into our component? And that's why what the ReasonReact bindings do. You don't have like a set state component, you have a reducer component. So you have kind of a micro Redux built in. A matter of fact, like an action is a variant, and it fits the definition of like an action really well, because it can be either this or that or that or that. But you also can have data in it. And in Redux, you have like type, and then you put in a string, and it's not really type safe, and it's really annoying if you screw up, because then we do constants to have it through imports and all the kind of like workarounds. But here you could just get all of this out of the box, and that's really cool. Matter of fact, like, I mean, Redux was inspired a lot by Elm, and that's because Elm has exactly the same concept. you have these, I think in Elm they're not called variants. I forgot how they call them, but in the end, it's just tagged unions, computer science, all the same stuff. Then I just do this as a helper because I really hate typing out ReasonReact.string. Then we have our reducer component. We have our make function again. This time it's a bit different because we set an initial state. We have our reducer, which again is just pattern matching. We learned this before. Pretty straightforward. And what's happening here is like we pattern match on a variant. And whenever we come to add, we extract the value and we update our state with basically count take the existing state and add to the state. With reset, we don't need the existing state, so we just reset it to 0. And then we have the render function, pretty straightforward. JSX, the only thing that's different in this case is, instead of curly braces, you have parentheses. And one thing that's important here, basically instead of like in Redux, you have dispatch, you just have send, which is simpler and nicer. All right, so that's how, basically that's mostly what you need to know about ReasonReact. The other stuff is just like look up the docs and it's pretty much the same. These were the specialities. There's one thing though, in the last 1.5 years, the things that I built, like I haven't used Redux at all because all what I did is I was fetching data with GraphQL and like, okay, that was a lie. Like I did one reducer in 1.5 years for the platform I was working on. And after seeing Sarah's talk yesterday, I think like, okay, we should have skipped Redux and just implemented with GraphQL local state. But well, if you're like this grumpy cat that doesn't like Redux and reducer component now because it's not fancy anymore, you can manage your state with GraphQL. There are people who actually made Apollo bindings, and this stuff is really good because actually it's way better than if you haven't used Reason or Reason Apollo yet. I'm pretty confident like you haven't seen this before because what we can do here with Reason Apollo is we can generate reason types out of our GraphQL schema, and that's really magic because you avoid a ton of like typing conflicts and annoyance of like typing out everything twice or 3 times. You just have your GraphQL endpoint, boom, I want to get that, and you're done. And again, the rest is done through generating types and type inference. Boom, no messing around. All right, last point. Interrupt with JavaScript. And there one is, we already heard the same guy that created React, Jordan Walk, is actually like fully betting on Reason now. I mean, he initiated this project. Nowadays, it has more. They call themselves like stewards, or other people call them stewards, working on Reason. But I think they consciously go the same path because to me, like one of the big things why we could adopt React, you could just get it in and use it in some place somewhere, like just a bit. And that's like, obviously you can rewrite your whole application with React, but you can have an Angular application or Ember or whatnot, and you just do this one piece, this one view you render with React. And that's really cool because that makes incremental adoption really easy. And so the same thing goes for Reason. They really care about that you can do incremental adoption, and that's why BuckleScript, this compiler, allows us to write bindings and in a really comfortable way. And you can it's not too complicated. And the best part is that ReasonReact actually opts in. Like it has 2 helper functions that allow you to wrap JS for Reason, which means you can take any existing JavaScript React component and use it in Reason with a little bit of code. I will show you in a second. But you also can do it the other way around. You can build your whole React UI library in ReasonReact and just wrap, wrap Reason for JS. And basically export your ReasonReact component for React.js to use. And here's an example where there's this UI library called Rebus. And we have this, that's a little bit of funky syntax where you define an external, don't want to actually go into it. But the end, the thing that matters is you have a make function, it has a direction, it takes a string, and you pass it down to the props of the JavaScript version of the rebus error. And the thing that you get then is exactly the same thing in JSX. You can use it in JS, you can use it in ReasonReact, you're all good. There's one thing though that specifically like trips me up all the time is with the arrow you have the direction, so we can say down. It's a string. The thing is, when I tried left, this happened. I was like, oh God. Okay. So what else can I try? Not right? Maybe. Better way instead of like monkey coding. We can go to the docs. These are the docs. They don't say anything about left, right, up, down. You don't even know if it works. So that's annoying. So I don't want to bash Rebus at all. Like, I think it's a fantastic library. And like, if we're honest to ourselves, like, this documentation is probably like 10 times better than what we all have with our internal UI libraries, because most of us don't have Storybook. So this is already really good, but I don't want to, like, the best thing I can actually do is go into the code and figure out like which options they support, and that's really annoying. So what we can do is we can use variance to the rescue. We can make this better. So when we use our arrow, we can define so we figured out only up and down is supported because we went through the code, but we have like 20 other devs that use our component. So we can define a variant. And in the end, like, our logic here gets a little bit like 5 more lines. But what we can do then is we can use this variant directly as a property, or like in this case, actually a labeled argument. And that's really cool, because if I do this here, arrow down, it will work. But if I do arrow left, it's not rendering, or I have to screw up anything, or like it's actually the compiler giving me a warning that this arrow left can't be found in the variant. Boom. That's exactly what I want. That's the magic that I want from like what I expect from my like when I code. I want to have a compiler that basically magically tells me like, hey, you screwed up here. Fix that, and everything will be fine. You wanna have this magic that analyzes your code, and you have no idea why it's doing it, but it just works. And that's quite fun. If you ask an audience, I mean, I'm not confident enough to ask a Finnish audience for questions, but if you ask an audience, usually like, do you want to have like a magic software that tells you about all the bugs you have, or not all, or most of the bugs you have in your code? They're like, yeah. And if you ask them like, do you want to have a static type system? No. But that's exactly the thing. Like, if you have a static type system with type inference, hell yeah, that's exactly what you want. All right, so what now? Should you go and rewrite everything you have in Reason right now? Go home and do this? No, don't be that person that falls off the cliff. Don't be that lemming. Like, just give it a try. You know, like, use this thing in like, replace one component in your production system. Do a fun project, do a personal project with it. Give it a try, give it a shot. Like, there are still glitches and hiccups that we have. Like, we are super early on. But I think like this is, I mean, I'm definitely a fanboy, so don't trust me on like whatever I say here. But like I think this will make coding and programming in the future way more fun and less annoying. And as Yuri pointed out, the like so if you're ready for the hype train. The React ecosystem right now is there, but if you want to create innovation and be right in that moment and create cool stuff, come and help us. Yeah, and the first thing we actually, like Andre told yesterday, we ran out of tickets. We added a couple of more, so if you're interested, you can join us at ReasonConf. What will happen there is first day is like everyone who gets a ticket. Everyone gets to the workshop, so it's like 1 day, full day workshop. And then the second day we have talks, and the third day is hackathons, and it's all included in one ticket. Yeah, and if not, just ping me on Twitter, happy to help. There's a Discord channel, which is yet another chat tool. But the cool thing is, if you ask a question there, like usually the time to response is like 3 minutes or something like that. People are really, really helpful in this community. Sometimes you even have like Jordan Walk reply himself or Cheng Lu. And yeah, that's about it. Thanks for listening. I hope this was helpful. And more Reason is coming in 10 minutes. Woo!